I want to use this video to show you how to use a scientific calculator to do the present value calculation for annuity. And then I will use Excel to double check the answer. So here we are provided with a 5-year annuity. But notice here it says daily compounding. This means that we need to work with the daily numbers for each input. That means we need to convert the number of years into the number of days by multiplying 5 by 365. And interest rate, this is annual percentage rate or APR. This is the default. By default, the interest rate is also quoted in annual terms. So here we need to get that into the daily interest rate by dividing 4.50 by 365. And payment here, that's the periodic payment. So here it's the daily payment. And the formula for the present value of our annuity is the payment times parentheses 1 minus 1 over 1 plus interest rate. The interest rate here is the periodic interest rate, and then raised to the power of t. T is the number of annuity payments, and then close that parentheses. So it's the 1 minus the whole chunk here divided by the interest rate. And then you just pull out this calculator here. First payment is 10. As we just said, this is equal to 10 and then times. Now I need to use the parentheses. Actually, using scientific calculators, the most common mistakes is missing the parentheses. Or sometimes you add in the extra parentheses. So we need to be very, very careful in doing this. I would recommend you that since adding parentheses doesn't hurt, but missing parentheses definitely will not get us the correct answer. So if you're not sure, you can just add parentheses everywhere if you want, but just don't forget that you need to put the parentheses in pairs. Don't use just one side of the parentheses and forget about the other side. As long as you use the parentheses in pairs, and then you will get the right answer. So here it's 10 times, going back to the formula, 10 is payment times, and then 1 minus that, right? So we need to use 1 minus, and then it's, remember this is 1 over, right? It's 1 over. So far, I didn't use, inside this parenthesis, I didn't use the extra one because the priority order for the arithmetic is that we need to do the division before the doing the subtraction, which is what we have here. So that's fine. But sometimes if we need to do the subtraction before we do the division, then we need to add parentheses. Here it's fine. So 1 divided by, and now I need to use the parentheses because 1 minus 1 over and then 1 plus that. So I need to use the parentheses and then 1 plus the interest rate. By interest rate, the APR is 4.5%. And then don't forget that we need to get the daily interest rate by dividing this by the number of days within a year, 365. And then this is 1 plus the daily interest rate, and then close that parentheses. So we are at basically at this stage, and then we need to raise this to the power of t. So 1 plus the interest rate, right? The whole thing raised to the power of t. So that I need to use the power function, which is x to the y's power. And then I need to use the parentheses again because the power t, I need to convert to 5 years. Remember, going back to the setup here, we have 5 years, but we have the daily compounding. So I need to get the number of days. I need to do the calculation again. And to do the calculation, I need to use parentheses. So 365, and then times 5, and close that. And so I'm basically at here. So after that, I need to close the parentheses again, because why do I close that? Why do I need to close that? Because I opened here 1 minus that, and if I don't close here, we'll miss a pair. Right? We don't have a pair. We miss one side of the pair. So we need to have a pair here. And then we need to divide everything by the interest rate again. So divide by the interest rate. But again, because we need to do the division, right? We need to get the daily interest rate. So for the calculation, I need to add the parentheses again. So it's 4.5%, 4.5%, and then divided by 365, and then close that. So just double check whether we didn't miss anything. I believe, yeah, we didn't miss anything. So 6341 point, if we keep 2 decimal places, that will make 0.68 to be the final answer. So let me just copy that number here. Okay, copy that number here and see whether we will get the same answer later. So this is what I got from the, so if I keep this to be the 2 decimal places, by changing, by format the cells, keep 2 decimal places, numbers, I get this number. So this is what I got from the calculator. And now I will use Excel to directly, and the function in Excel is equals PV function, to directly calculate this present value. So if I open this equals PV and open it, you can see that the first argument is rate. This is the periodic interest rate. So I need to get the daily interest rate by dividing this APR by 365. And then the second argument is the NPER. So this is the number of payments. So that will give us it's the number of years, and then times 365. And then the third argument is the payment. So the rule for either financial calculator or Excel is that if you use a positive payment, and then your answer for present value will be a negative value. So if I want to get a positive present value, I need to put this payment into negative terms. So I put that negative and then this payment here. And the fourth argument is the future value. Here we don't have any future value. All the future value are in the form of the payment, annuity payment. So then I can just close this. So you can see that either using Excel or a scientific calculator, I get exactly the same answer. I hope this video is useful to help you to master the skills in using either calculator, a scientific calculator, or Excel to get the same answer.